The American Meteorological Society's policy program is supported, in part, by a public-private partnership.
There is growing recognition in Congress that improvements in weather forecasts for the time span of 2 weeks to 2 years could have major social and economic benefits. Seasonal forecasting is the focus of current legislation and is the subject of several Hill briefings, both from earlier this year and in development for the next few months. This interest in seasonal forecasting is also reflected in the scientific community. The National Academy of Science is currently conducting a study on the future of seasonal forecasting research that will come out later this year. I've had the opportunity to sit in on several of the study's meetings where they heard from experts at NOAA, other federal agencies, and many universities, and it is clear that some of the brightest scientific minds are working on improving our seasonal forecasting ability. The reason we're here today is to discuss the reason why seasonal forecasts are important. We'll hear from experts in agriculture, energy, and fisheries on how they currently use seasonal forecasting information and what they would do with improved forecasts. I hope that you'll walk away from this briefing with a better understanding of how seasonal forecasting information is valuable to each of these sectors and of some of the opportunities and challenges in applying new seasonal forecasting information to decision making. After the presentations, we've scheduled a generous amount of time for question and answer, so I do ask that you hold your questions till the end. And with that, I will turn to our first speaker. Mark Brusberg is Deputy Chief Meteorologist with the U.S. Department of Agriculture's Office of the Chief Economist, one of 5 agricultural meteorologists providing domestic and international crop weather assessments in support of USDA's Global Situation and Outlook report. Mr. Brusberg is the international editor of the Weekly Weather and Crop Bulletin and is involved in the production of the North American Drought Monitor. He is also active in efforts to strengthen the partnerships between USDA and other federal departments through programs like the National Drought Resilience Partnership. Mark. This is
Okay, thanks. Thank you. I really don't have anything else to say about myself, so that was nice. I'm not going to mess it up by trying too hard. Anyway, I want to thank you. I am an agricultural meteorologist, and a lot of people ask me what that means, and I say, well, I'm a meteorologist, and I follow crop patterns, crop growth. I monitor other countries and see how their crops are doing. So when I was asked to talk, we were given a series of questions that were germane to the topic, and the first one was, how is my sector affected by seasonal variations in weather? As I go through these, I'd like you to keep in mind some of the things that we're looking at and how those can be translated into the seasonal forecasts. Some of the things that we look at are pretty much no-brainers. I mean, we look at precipitation. There's a copy of the drought monitor in a flooded field there, but we look at the seasonal accumulation of rainfall, and that's something that we can get from a seasonal outlook. But one of the things that crops are dependent upon is timely rain, and they can't really stand, depending on the soils or other parts of the climate, they can't really take extended periods of dryness. So if you have a long-term forecast that says, okay, it's going to be wetter than normal, that doesn't always mean that the rain is going to come right when the crops need it. So we're looking at a different time frame. Sometimes we're looking at days or maybe hours long events, and that's something that to improve the utility of the outlook, we have to get that type of information out of it. The other thing is temperatures and heating units up there. Is it warm enough to let the crop grow from beginning to end? Are we trying to grow cotton too far north, et cetera? Now, most farmers know what types of crops their climate can handle, so that's usually not a problem, but was the heat that they had stressful? I mean, there's a big difference between a corn plant growing at 85 degrees and 95 degrees, especially when it's flowering. So those are the types of things we're looking at. There's a nice picture of frozen oranges on the right there. Are they having freezes? Is that something that you could have foreseen looking at a long lead outlook? And also, what is the season length? In some parts of the country, notably the northern ones, the Canadian prairies, they look at the length between the last spring freeze and the first freeze of autumn. Is that something that a long lead outlook can tell us? You know, when is the last freeze going to be? If it says there's a likelihood that it's going to be a cool autumn, does that mean that there's going to be an early frost? Is that some information that we can make an assumption about when we look at the outlooks? And there's also, like I said, the 1 day to 1 hour events. You can have flash flooding and just, you could be in a drought and then just have a couple of days of very heavy rain, or have remnants of a tropical storm sit over your region and flood you out, okay? You could still be in a drought, but then have flooding of low-lying farmlands. Hail, there's a good picture of corn that was damaged to the point where it disrupted the growth hormones and it's starting to sprout. So it made that ear unusable. And then you have high winds, and in the case of forests, we watch lightning. So those are the things that we're looking for in monitoring agriculture. Now, some of those things are easily forecast in advance. Some of them we're lucky to get a few hours notice of. So that's just the nature of the science of forecasting as it is right now. And also sort of an offshoot are diseases. Diseases and pests. If it's a very wet spring or summer forecast, the farmer might say, maybe I should stock up on pesticide or fungicide, something like that. However, if it's very rainy, if it rains every day, they won't have an opportunity to apply it. So that, again, that's a cost decision that the farmers have to make based on the forecast that they get. Now, here's the second question. Is how are seasonal forecasts used for management decisions in the Department of Agriculture? It would make sense that a lot of us use forecasts in our decision making, but that's not really the case. Some of the management decisions are based on climatology, just knowledge of what should be happening, and then some of the folks actually are responsible for projecting out what they think is going to happen. Let me introduce you to some of the things that the department is interested in. The Global Monitoring and Assessment, that's my agency. It was mentioned earlier, I'm involved with the Weekly Weather and Crop Bulletin, but Forest Service has a big concern with fire weather, and our Natural Resources Conservation Service looks at the Western Water Supply forecast. And then we have research, and Risk Management Agency looks at the crop insurance program. So they need to know what the weather is going to be like, or in the least they have to know what the expected weather is, and I'll get to that in a moment. Now this is a table that I took out of a submission that I made to the Office for the Federal Coordinator for Meteorology. They did a data call, and they wanted to know what agencies in USDA had agency operational costs. There's only 4 agencies that have operational costs related to weather. Okay, there's the Office of Chief Economist, my employer, Risk Management Agency for ag and land management issues, and Hydromet and Water Resources is NRCS, and then of course the Forest Service is the fire weather. So that's, out of all the agencies in USDA, there's 4 that make management decisions using weather information. Now let's talk about my agency for a moment. One of the things that we do is we put out a very market-sensitive economic report. We call it the WASDE. It's the World Ag Supply and Demand Estimates Report. And if you look at, do I have a pointer here? Top button. Okay. Well, you have to take my word for it. I'm pointing at that yellow box. We look at the weather in other countries to see what's going on. In this case, there was a drought in Russia and Kazakhstan, and we reduced the crop. Okay, and that's what we're looking at. We're looking at what actually happened. Now, we are asked why or if we look at forecasts. Now, here's an example of a forecast. This was last year, and there was an El Nino expected to develop last year. If anybody's following the El Nino, it didn't develop last year. Okay, so we were told, hey, there's an El Nino that's going to develop. We're looking at this. We're concerned about this. People are saying, hey, you better be prepared to reduce the wheat crop in Australia. We didn't do it. And here's why. Well, first of all, the El Nino didn't happen until this year. But, you know, you would expect there to be dry weather in Australia during an El Nino that would impact the crops. Now, here's a trend series for wheat yields. And that red line is the trend. The green line are the actual observed yields for those years. And I put red circles on years where they had El Ninos. And it looks like a no-brainer where you would expect there to be a below normal wheat yield during an El Nino year. But look what happened. 1997-98, which was the strongest El Nino to date. They think that this one might be stronger, so that's why we're watching that. The strongest El Nino to date, they actually had really nice yields. And the reason was it rained. There's the other three El Nino years, the red, the blue, and the green line. But 1997 is that light blue line. They had rain, and it was very timely rain. Remember, I talked about the timeliness of the rain. They went through extended periods of dryness, but just when you thought the crop was in trouble, they'd get an inch of rain, or they'd get 2 inches of rain. So it was right when they needed it. So that's, and we ended up not making a mistake. There was a lot of pressure for us to lower that crop. We did not, and we ended up having to raise the crop. So that's why we're very conservative when we look at what we do and try to see what the forecast is telling us to do. The Risk Management Agency, they have some tools that they put out for farmers. This particular slide is showing the rainfall index and a vegetation index. And what they do is they look at the climatology of an area, and then they leave it up to the producers to see whether or not they want to have buy insurance that year. So the producers, the farmers, ranchers, they have the opportunity to use these tools. They can look, if they have a contract with somebody who's making recommendations to them, they can look at the long lead outlooks. RMA does not. They just look at the climatology. Natural Resources Conservation Service, they run their own models. And I'll talk about them a little bit more in a minute, but they run their own models. They look at antecedent moisture conditions, snowpack, stream flow, and then they have statistical models, and then they have dynamic models that they run. So they run their own models. They don't look at the outlooks. Maybe they will one day. The Forest Service, they are part of the group that issues the wildfire forecast. As partners, the National Weather Service provides their outlooks, and they use the outlooks when they're developing this fire forecast. So out of the 4 agencies in USDA that, administrative services that look at weather, one agency does not, just because they're very conservative and they're afraid to be wrong. RMA, they have constituents that look at outlooks. The Natural Resources Conservation Service, they make their own outlooks because of the models. They're very complex models looking at the soil moisture and the snowpack. And then the Forest Service does depend on outlooks. So really, I guess you could say there's more opportunity for us to use long lead outlooks, but there it is. I mean, we do have the ability to look at weather and climate data, but like I said, sometimes we are a little bit more conservative than a lot of people would like us to be. Now, here's the last question. What would the benefits of improved seasonal forecast be, not just to USDA, but to the ag sector? And if you can see, that's that lovely map that Climate Prediction Center puts out, thank you, every month, showing just a myriad 3-month forecasts. What really happens? Well, Agricultural Research Service of USDA, which is the research arm that I didn't talk about because they're not operational, did some studies on what outlooks mean to the ag sector. And I'll let you go to their site. If you just Google ARS and climate outlooks, you'll get this page. They looked at where the best opportunities were. And obviously the best opportunities are where the forecasts do the best job. And so they mapped that out, and they were saying, well, if a farmer or a rancher wants to make a decision based on the outlooks, these are the areas in red on the right-hand map, in red and in green. These are where the outlooks did the best. So you probably have a better chance of being right using the long lead outlooks. How can these be improved? Well, the recommendation, not just with the outlooks, but also in climate change is, hey, let's get these climate forecasts down to a region. Let's downscale these models. Okay, so that's one of the opportunities for improvement, looking at the scale. Now, looking at some outside studies, and I'll just go through a couple of these briefly. There was a workshop in Australia sponsored by the FAO about 10 years ago, and they looked at how the seasonal climate forecasts were looked at by agricultural users worldwide, and they were saying that there is a disconnect. There's a disconnect between the farmers and the people making the forecast. Sometimes they don't understand the forecast. Sometimes they don't know exactly what that means to them. Remember, I gave you the example where it was warm, but was there a heat wave? Or if it's cool, does that mean there's an early freeze? They might look at that and say, what does this really mean to me? So there's a good opportunity to explain that. And other things, some of the problems that we have is with confidence. And if you read that, it's basically people are going to remember a bad forecast. So if a farmer or rancher pays for a forecast and it's wrong, they're going to remember that. Sometimes they are wrong. Was it explained well enough to the person? These are the risks, these are the limitations of the outlook. And recommendations to the water management community, these are the things: accessibility, interpretability, credibility, and relevance. That's what the ag sector needs in a forecast, okay? And that's not just a product of the National Weather Service or whomever spitting out the forecast. They need it to be a one-on-one, back-and-forth explanation. Here's what I need. Well, here's what I can give to you. And finally, I just want to leave you with this. This is a chart showing the snowpack in California on April 1, and I've outlined the El Ninos. Now, we've heard in the press that, yay, there's going to be a strong El Nino. That means California is out of the woods. Well, this is why people are saying California is really not out of the woods, because if you look at those circles, the darker red circles are the strong El Ninos, and 1983, they had good snowpack. 1997, April 1, the snowpack was good, but there were some other years where it wasn't that good. Okay, so again, there's reason for optimism this year, but it's not a deadlock. Okay, so really to summarize, the ag sector is affected by a lot of weather events on different scales. It would be really nice to have really good seasonal forecasts, but sometimes there's information in the seasonal forecast that really, it begs more questions. And I gave you a few examples of that. USDA, I think we can benefit from improved forecasts, but our use of them is probably always going to be limited to certain agencies. But then again, farmers and ranchers, foresters are our constituents, so we would like to see them benefit as much as possible. And again, there's a lot of challenges. And I think the main challenge right now is communication between the people making the outlooks and what that really means to the sector that's trying to use it. And again, thank you for having me here. That's all I have, and I'll be here for questions afterwards.